we're going to integrate the square root of 25 minus x squared. The integral is of a radical that looks like this, square root a squared minus x squared. We're going to match the constant, so a squared matches to 25, and therefore a, we can take it to be the positive square root of 25, which is 5. The standard substitution for integrals like this is to let x equal to a times sine of theta. In our case, we already know a, it is 5, so the substitution is x equal 5 times sine of theta. Differentiating, dx is 5 cosine theta d theta. Let's replicate what's inside the radical. We're going to square our x, which is 25 sine squared theta. Then subtract that from 25. 25 minus x squared is equivalent to 25 minus 25 sine squared theta. Factoring 25, 25 times 1 minus sine squared theta, which is 25 times cosine squared theta. That is what we'll be putting into the integral inside the radical. This will eliminate the radical and help us solve the problem easier. So the integral becomes the square root 25 minus x squared is now replaced with 25 cosine squared theta, and dx is replaced with 5 cosine theta d theta. Assuming the square root of cosine squared is cosine, square root of 25 is 5, we get 5 cosine theta times another 5 cosine theta d theta. And this is equivalent to 25 out in front times the integral of cosine squared of theta. To evaluate this integral, it's done in an earlier video. You can review it, but we replace cosine square with a trig identity, 1/2 times 1 plus cosine of 2 theta. And so this is equal to 25 halves times the integral of 1 is with respect to theta is theta. The integral of cosine of 2 theta is 1/2 sine of 2 theta. Multiplying through by 25, we have 25 over 2 times theta plus 25 over 4 times the sine of 2 theta. We need to apply one more trig identity, and that is we have the 25 over 2 theta plus 25 over 4. Here's where identity needs to be applied. Sine of 2 theta is 2 sine theta cosine theta. So this is 25 over 2 theta plus 25 over 2 sine theta cosine theta. Now, this is the answer in variable theta, but our original integral was in variable x. So our final answer must also be in variable x. Let me summarize this. We had an integral 25 square root of 25 minus x squared, which we evaluated as follows by making the substitution x equal to 5 sine theta. We came up with a solution in variable theta as 25 over 2 theta plus 25 over 2 sine theta cosine theta. Now we need to replace theta with x. So here is our substitution. Let me rewrite it like this. Sine theta is x over 5. It's the same thing as x equals 5 sine theta. We draw our right triangle. This is the right angle. We call this angle theta. Now sine is opposite. I call this side x. Over hypotenuse, we call this 5. The missing side will be the square root in the integral, which is square root of 25 minus x squared. You can easily check that by applying Pythagorean theorem. So our final answer is this. Now from this definition, sine theta equals x over 5, applying inverse sine to both sides, we get that theta is inverse sine or arc sine of x over 5. And so our final answer now in variable x is 25 over 2 theta, which is inverse sine of x over 5, plus 25 divided by 2 sine theta. Now sine theta is x divided by 5 by the very definition, times cosine theta. And from this triangle, cosine is adjacent side over the hypotenuse. So that's square root of 25 minus x squared divided by 5. And then we add a c at the end. So to summarize it, the final answer after simplification looks like this. The integral of the square root of 25 minus x squared is equal to 25 divided by 2 times the inverse sine of x over 5. And notice here, 25, we got a 5, and the 5 here cancel. So this is plus x times the square root of 25 minus x squared. The only thing remains in the denominator is 2. Then we add c